All right, in this lesson we're going to talk about writing linear functions. We've already talked about graphing linear functions in several examples. Let's talk about writing linear functions. Here's some forms that we might see of linear equations, some we've already talked about. The slope-intercept form, y equals mx plus b. Notice the number in front of the x is the slope. The y-intercept is the constant. Point slope form. This is a formula that you're going to need to memorize. This is one that we'll need to know later on, so I'm going to go ahead and circle that one. That's one that we definitely need to know. To use this, if we're writing equations, we're going to plug in the point x1, y1 into the formula. And if you know the slope, you can plug it in right there for the m. So this is used in writing equations of lines. Standard form says if you've got your x and y on the same side, your a has to be positive. A, B, and C cannot be fractions or decimals, so you got to make integer coefficients. We'll talk about that some more as we progress. And have already talked about graphing a horizontal line where you just have y equal to a number, or a vertical line where you have x equal to a number. Remember, a horizontal line has a slope of 0, and a vertical line has an undefined slope. So you can look at this summary some more, and maybe that will help you with some of your forms of your lines. But this formula I've circled here, this is one we're going to use a lot in this lesson to write equations of lines. So we've talked about the slope formula before, y2 minus y1 over x2 minus x1. So if you've got 2 points on a line, you can find the slope. You've looked at those also in function form, but this is the same formula. It's just written in a different way. And then this is the point slope formula where we can use to write equations of lines. Remember, for the point slope formula, we're only going to plug in the point x1, y1. So in for those numbers right there. And then we're going to also plug in for the slope of the line. So let's do a couple of examples here. Write the equation of a line that has a slope of 2. So they gave us the slope. The slope is 2. Passes through the point -2, 1. So since they gave us a point we want to go through, we're going to label that as x1, y1. Now let's review. The point slope formula is y minus y1 equal to slope m times x minus x sub 1. So I'm going to plug in for the point x1, y1, and then the slope right there. So let's plug our numbers in and see what we get when we work this out. So y minus y sub 1 in this problem was just a 1. The slope they gave us was 2. That's times x minus x sub 1 is -2, so minus 2. Okay, so let's work this out now to clean it up a little bit. So I have y minus 1 equal to 2 times, that's actually going to be x plus 2. Minus minus makes a plus. So if I do the distributive property on the right side, so 2x plus 4, I'm getting this close to looking like the slope-intercept form. The last thing I need to do is get that 1 away from the y. So it says minus 1, I'm going to add 1 to both sides. So my equation for my line in slope-intercept form would be y equals 2x plus 5. Now again, this equation is in slope-intercept form. Pay special attention to the instructions that you're given in the problems that you're working. If they ask you for slope-intercept form, you would be done with this problem. If they ask you to write your equation in standard form, if you remember that, then we're going to have to do a little bit of work on it. So standard form, we're going to move that 2x back over to the left side, so that'd be -2x plus y equal to 5. Now, for it to be correct standard form, I can't have a negative number out front, so we're going to have to multiply through by a -1 to get rid of that. So 2x minus y equals -5 would be the correct standard form for that equation. But slope-intercept form would be this version of the equation. Write the equation of a line that has a slope of -3/4 and passes through the point -8, -3. So this example is just like the one we just got through doing. Let's label some stuff. We've got the slope given to us, and then this will be x1, y1. So let's plug our numbers in and just work this out. Y minus y sub 1, so in that case it's going to be -3. Y minus -3 is the same thing as y plus 3, equals -3/4 was my slope, times x minus -8, so that's going to actually be +8. So this time we have to worry about that fraction, but that's no biggie. We can deal with that. So we got y plus 3 equal to, I'm going to do the distributive property on the right side. So that's -3/4 x minus, so it'll be -3/4 times 8. You can use your calculator, or if you know how to multiply fractions well, you can just do that. 3/4 times 8 is 6, so it's just going to be -6. So the last step I need to do is subtract the 3 to get that y alone. So y equals -3/4 x minus 9. Now that is the slope-intercept form of that equation. Now, if the instructions had told us to write this equation in a standard form, what we would have done here is we would move the x back over, of course. So I would have 3/4 x plus y equal to -9. But the rule for standard form is that you cannot have any fraction or decimal coefficients. So if you remember from earlier algebra classes, I can clear the fractions out by multiplying through by the common denominator. In this case, the common denominator would be 4, so I'm going to multiply everything by 4. So those will cancel out. I would be left with 3x plus 4y equal to -36. And that would be the correct standard form of that equation. Now, if they specifically say find the linear function, then that should be telling you that you want your equation to be f of x equals form. So you want this slope-intercept form of this equation when you're writing your final answer. Now, they gave us a couple of points here, so we're going to have to do a little bit more work than we've done in previous examples. They said find a linear function that contains the points f of 3 equals 3. So we know that's the point 3 comma 3. And then f of -2 equal to 6. We know that's also an ordered pair. So they did not give us the slope in this problem. However, we can find it using the slope formula. M equals y sub 2 minus y sub 1 over x sub 2 minus x sub 1. So let's label our points so we make sure we get that correct. We know that one will be x1, y1. The other one can be your x2, y2. And that way we'll be sure to put them in the right order. So 6 minus 3 over -2 minus 3. So working that out, I get 3 on top and then -5 on the bottom. So my slope is -3/5. So to write the equation, we're going to use our point slope formula, y minus y sub 1. So I'm going to use my 3 equal to the slope, which is -3/5, times x minus x sub 1, which we're going to use the 3. Some of you may have a question right here if you should plug in the 3, or if you should plug in the -2, 6. It actually does not matter as long as you stick with the same point as you're plugging in your x and your y and your x. Make sure that you stick with the same point. So I'm using the x1, y1 just because that's kind of how the formula calls for it. So let's work this algebra out. So I'll have y minus 3 equals -3/5 x, and -3/5 times -3, that's going to be plus 9/5. So the last step I need to do is add 3 to both sides. Now you can use your calculator if you want to do this, or you can get a common denominator and combine your fractions. 9/5 plus 3, I'm just going to punch it into my calculator. I got 4 and 4/5, which we know is a mixed number. I want an improper fraction. 24/5. If you get a mixed number on your calculator, all you have to do is do your shift or second function key, hit your fraction key again, and it will change it to the improper fraction. So if we wanted a linear function, this is actually the form that we want our equation in because it's already solved for y. So we don't want to do a standard form on this at all. It's -3/5 x plus 24/5. That is linear function form. Now, some things you talk about when you're writing equations for linear functions, that type of thing, they may throw in some vocabulary about parallel and perpendicular lines. Okay, I got some stuff covered up here. Let me move that. If two lines have the same slope, they're parallel. Parallel lines never intersect and their slopes are always equal. If lines are perpendicular, then their slopes are negative reciprocals of each other. In other words, you flip the slope and change the sign. Now, perpendicular lines are like a T or a perfect L shape where you have actually a 90-degree angle that's formed. So that's the example of perpendicular lines. The slopes are negative reciprocals, which means you're going to change the sign and flip the slope of your line to find the perpendicular slope. So let's look at a couple of these examples here. It says, find the slope of a line that is parallel to y equals 2x minus 1. Well, that's pretty easy because this is already in slope-intercept form. The slope of this line is 2. So the parallel slope, the slope of a line that's parallel, would also be equal to 2. So the slope of a line that's parallel to this one, you're going to have the same slope if they're parallel lines, so it would be 2. Now, find the slope of a line that's perpendicular to the line, -3x minus 2y equals 8. Now, this is not in function form. You could solve it for y. But we also had another formula that we could use for the slope if your equation is given in standard form. It's -a over b. So in this case, it's -3 over -2. So that's going to be +3 over -2. The slope would be -3/2 of that line. So what would the perpendicular slope? Well, we said earlier that the perpendicular slope is flipped and the sign is changed. So it's going to be positive instead of negative this time. And so it's -3/2. We're going to flip that and make it 2/3. And remember, we're going to keep it positive. So the slope for a perpendicular line, you're going to flip it, do its reciprocal, and then you're going to change the sign. So look at this problem. Write the equation of a line that is parallel to the line 3x minus 4y equals 6, and then contains the point -4, 9. So we're writing another equation here, but it's going to be parallel to this line. So I need to find the slope by finding the slope of this line. So it's in standard form. We know the standard form equation for the slope is -a over b. So that would be -3 over -4, which comes out to be +3/4. The slope is +3/4. So that is actually the slope we're going to use for our equation as well. So we have the point -4, 9, which I'm going to label as x1, y1. And use my point slope formula to write this equation. So y minus 9 equals the slope, which is 3/4, times x minus -4, which we know would be +4. So then work out your algebra. 3/4 x plus 3/4 times 4 would just be 3. And then the last step, add the 9 over. So y equals 3/4 x plus 12. Now, if they asked for the answer in slope-intercept form, then this is what you would leave. That's your function, your functional form. Now, if they wanted the equation in standard form, let's talk about that for a second. If we want to write this in standard form, first thing I would need to do is move the 3/4 x over to the other side. So I'd have negative 3/4 x plus y equal to 12. I need to clear fractions, so I'd multiply through by 4. So that would give me negative 3x plus 4y equal to 48. And I would also have to multiply through by a negative 1 because a is not supposed to be negative. So I would get 3x minus 4y equal to negative 48. Notice that the left side of the equation, the 3x minus 4y, matches what you've got in this equation. They were supposed to be parallel lines, so those would have to match. In that case, they do. So this is the standard form version of the equation. A lot of forms you have to keep in mind as you're doing these problems. This is just a slide here I've put in to just kind of reinforce how you write the standard form of the line. AX plus BY equals C. Remember, A can never be negative. And A, B, and C have to be integers. You can't have any fractions or any decimals. So let's do one more equation, one more problem. We're going to talk about perpendicular in this problem. Find the equation of a line that is perpendicular to the line y equals negative 4/5 x minus 5, and then contains the point negative 4, 3. But in this case, it said express your equation in standard form. So we specifically told you what form we want the final answer in. Now, it says we want the equation of the line that's perpendicular to this. What would the slope be of this equation? Since it's already in slope-intercept form, we can tell that the slope of this line is negative 4/5. So my question would be, we want our line to be perpendicular to it, so what slope would we use? So if we want it to be perpendicular to negative 4/5, we're going to have to flip it and change the sign. So it's going to be positive 5/4. That would be our slope, positive 5/4. All right, so we now have our slope, and we have our point x1, y1. I'm going to go back to my little trusted point slope formula. Y minus 3 equals 5/4 times x minus negative 4, which will be plus 4. Work out your equation. 5/4 x plus 5/4 times 4 would just be 5. Then I'm going to add my 3 to both sides. So y would equal 5/4 x plus 8. So we know that's in slope-intercept form. We want to write our equation in standard form. So I'm going to move my x stuff over to the left. So negative 5/4 x plus y equals 8. Multiply through by 4 to clear the fractions out. So I've got negative 5x plus 4y equal to 32. And we also know with standard form that the a, or the leading coefficient, cannot be negative, so I'm going to change all the signs. 5x minus 4y equals